Now let's check out the other application that comes with Anaconda distribution, which is the CLI application command line interface application called Conda. So I'll follow the cheat sheet or this list of commands and subcommands from the Anaconda official documentation so that we can practice and execute these commands and show you how to follow a basic workflow for creating your environments, installing packages specifically on that environment for each project you create, and then open that in a integrated development environment, selecting that environment as well as all the packages installed through Conda at that environment. So at this quick start session, it starts already remembering again that it's recommended to create a new environment for any new product or workflow. So anytime you want to create a new product, whatever IDE you plan to use, in case you want to use virtual environments, you should actually start by creating a new virtual environment instead of using the base environment as we've already commented, because the base environment is not for us to change or to use in our development. It's basically for the base function of Conda and Anaconda Navigator. So the base environment, it's like an environment for Anaconda itself to work, and for our projects to work in a virtual environment, we should create new environments for each project we create. So at this initial page of the commands list from the documentation, we have some very important commands: Conda create, the Conda activate, and advancing a little bit, the Conda deactivate. So we'll now test these three commands. Observe that all commands start with Conda. Conda is the application we'll be using, and any commands we do through Conda will start always by the word Conda, followed by the subcommand according to what we want Conda to do. So in this case, we'll test now the Conda create for creating new environments. For a simple project, we will also create. So we'll create a project folder, and inside that folder, we will create an Anaconda virtual environment. Then we'll activate that environment for letting it ready to be used. And then we'll load it at some IDE in order to continue the creation of the project, do all the coding and building, and then deploy of our sample application. Let's go to the terminal. So let's start by creating the workspace and the project folder of the new project we are going to create. The workspace I already have here at my home. I call it Anaconda-workspace. You can call whatever name you want, but it's important that you have a workspace for all your Anaconda projects to be organized inside. So inside the Anaconda workspace, I already have some projects that I have created before, but as we are going to create a new project, a sample project for testing these initial Conda environments, we can simply create a new one that I'll call test. This is the folder for the new Python project that we are going to create, and that for now has nothing inside, but when we create the environment, you'll see that a new folder here will appear with all the virtual environment files and folders inside. So always create your virtual environment inside the folder of your project to keep it easier to find, and for not mixing that virtual environment folder and contents with other projects virtual environments content. We can close here, get back to the terminal. If you see, now I'm at my home path. As we are going to create a virtual environment, first we gotta go to the folder of the project where we want that virtual environment to be placed at. So let's go to the folder I've just created, which is at my Anaconda workspace inside the test project folder. So this is the path or the folder for the project test that we're going to create. So we gotta create our virtual environment inside this particular folder to let all the contents of the virtual environment inside the same folder of the project. So, and as you see, let me show you the content here inside. There's nothing inside yet. So let us use the Conda create command and subcommand and some attributes to create a virtual environment that I'm gonna call test-env inside this project folder test. So, and how we use the Conda create? By simply typing Conda create, and now you have two options. You can use the attribute --name or the abbreviation -n to simply pass the name of the virtual environment you're creating. For example, test-env, and we'll not be using Conda create this way, but I'm just showing you now once for you to know what happens if we use the attribute --name. So press enter. If you take a look before confirming the creation of the virtual environment, Conda actually confirms where the virtual environment folder will be placed at in your file system. So if you use the name attribute here for the Conda create, Conda will not place the environment at the project test or the project you're creating where we want it to place it, but instead it will place into a default folder called envs, and we do not want that, but I'll just confirm here for you to see that that's actually true. So okay, and it has created the test-env virtual environment at this place where we didn't want, because it's outside the project test folder, but let's check there. So if you go here at your home and select the options here, show hidden files, you will notice a folder called .conda at the home, and inside this .conda folder there's a names folder and there's a packages folder. So if you go here to the envs, you will find the folder of the virtual environment we've just created, the test-env folder, here at the home /.conda/envs, and inside the test-env folder you will find the content of the configuration for that just created virtual environment. This packages folder here at the home /.conda is actually the folder for all the packages that are already downloaded locally from Anaconda, so that Conda application can use those locally available packages at this local repository inside this packages directory here, instead of downloading them from any remote repository. So first Conda will check inside home /.conda/packages to see if the packages we're asking it to install at any virtual environment exists locally, And if those packages do not exist locally, only then it will go to the remote repository and download it to this exactly same folder here inside this hidden folder .conda at the home folder. So these packages are not for the virtual environment we've created, which is placed here inside the env folder and inside the test-env folder, but they are all the packages available locally, ready for Conda to use to install inside any of the existing virtual environments created. But as I said, we do not want to create our virtual environments outside the respective project folder, so we do not want to create them here at the env folder. So we can simply delete this folder, or let me do it using the CLI interface. So first, for activating a created environment, you can simply use conda activate and the name of the environment, in case that environment has been created using the name attribute. So I'll leverage this case for you to know that for activating the environments placed inside that env folder, that default env folder, you simply use conda activate and the name of the virtual environment without any path. Why? Because Conda will know where that package by default has been placed. We do not have to pass any path, only the name of the virtual environment. So for activating it, we use conda activate test-env. Okay, and as you see, now the prompt has changed and the name of that virtual environment created with the -n or -- name has appeared here between parentheses. And observe that no path has been added to the name here, because we are not using the prefix. That's the second option we can use, and that we'll be using for the rest of the course. But now I'm showing the case that we do not use the prefix, but we use the name and only the name. So if we use the name for creating the environment, after we create it, inside that default env folder, can activate only passing the name of the environment, and here at the prompt it will appear also only the name between parentheses. So in how to deactivate, you can simply use conda deactivate without having to pass any name, because the only option to deactivate is the current activated single environment test-env. So it will simply deactivate. And if you see again, there's no more environment activated because there's no virtual environment's name between the parentheses anymore. It's only the normal prompt with the group name, and the name of the machine. So that's how you create a virtual environment using the name parameter, then you activate it, and then you deactivate that virtual environment. So, and as we do not want that environment to be placed at that default env folder, I'm actually gonna remove it. So, and how do we remove or delete a virtual environment already created? We simply delete or remove all packages inside it by calling conda remove the name of the environment, which in our case is test-env, and we also use the attribute all. So it will remove all packages from inside the test-env, and we are not passing any path here because we have created at the default env folder, so we do not have to pass the path. We only need to pass the name. And when it removes all the packages inside this virtual environment, it simply deletes or removes the environment. from that default package. Confirm. Okay. Now let's go to the folder envs again to see if the test-env virtual environment has been actually deleted. So here at the home, you go to the Conda, envs, and as you see, there's no more virtual environment folders anymore, including the test-env folder. So the folder has been deleted along with the test-env environment and all the packages inside, which actually did not exist because we didn't install any package at that environment, because we're just showing you how to create environments using the -- name. Okay, so and as you can see here also, there's no content still inside this project's test folder. And now let's use again the conda create command, but now instead of using the -- name, let's use the -- prefix or -p, which is the second way of using the conda create command. And with the -p or prefix, we will not pass the name of the virtual environment alone, but the whole and complete path to that virtual environment, or the exact place in our file system where we want that virtual environment to be placed into. So where we want our virtual environment to be placed inside this current folder we are at. So conda create -p, then you gotta pass the complete path to this folder where we are in. You can use the home abbreviation for not putting all the path since the root folder. So home / anaconda workspace / test. So this is the place where we want our virtual environment folder to be placed into, inside the same folder of the Python project we are creating. So we could not do that with the name attribute, but we can do that with the prefix attribute. So with the prefix attribute, we pass the whole path, and at the end of the prefix, we then pass the name of the virtual environment we want to create. And now use again the same name, test-env. So conda create -p home / anaconda -workspace /test /test-env. So for creating the environment, you only have to use this, and it will create a virtual environment here inside this Python project folder without any package installed. But as we need to install some packages, at least the Python package we need to install. So here after the prefix, we then can pass a list of packages, for example, the Python package with or without any specific version of that package. So if we do not pass the version, Conda will take the latest stable version for that package and install it. But if we want some specific version of that same package, we only have to use the double equal with the version we want. For example, I'll not ask it to install the latest 3.12, which is the latest stable one, but the 3.11. So this is the version of Python that Conda will install at this virtual environment called test-env. And we can pass also some other packages, for example, pandas and numpy. We are asking Conda to do two things. Firstly, create this environment test-env, and secondly, install these three main packages, and in the case of Python with this specific version 3.11 at this virtual environment. we are managing environments, and we are managing packages in one same command line statement using Conda. So just press enter. If you go up here a little bit, you see that now, instead of creating the virtual environment at that env's default folder at the home, it will create the virtual environment folder with all the content needed inside at this path at the prefix, which is at my home / anaconda -workspace /test, which is the folder for our Python project we'll be creating, /test-env, which will be the folder with the content of the virtual environment. So the content of the virtual environment will be inside the folder of our Python project. So that's the best practice to do, so that you can keep everything needed inside the project you're creating. So always create the virtual environment using the prefix so that you can set the exact place where you want the virtual environment content to be placed at. And here, right below, it confirms the 3 main packages we are asking it to install, which are numpy, pandas, and Python. And in the case of Python, the specific version 3.11. So in here below, observe that it lists a greater list of packages that it has to install in order that these 3 packages we've asked Conda to install actually work. So these 3 packages we want Conda to install will actually depend on a bunch of other packages. So Conda not only takes responsibility of fetching and installing the packages we want, but also is in charge of fetching any other related dependencies. And not only that, but fetch the right version and build of those so that all the packages installed can work together without any conflict or without any incompatibility. So here is the total list of the packages that are going to be installed, and it includes the whole dependencies and the 3 ones that we asked Conda to install, which are numpy, pandas, and Python. And in the case of Python, if you see here, it will be Python version 3.11. And here on the right is the build of the package. Okay, proceed, yes. So now it's doing all the transactions for the installation, and it has finished. So right when Conda finishes installing packages and creating the environment, it shows this success message here, which basically tells how to activate the environment just created along with all the packages installed. So to activate, we can simply use Conda activate, and then the whole prefix. Observe that now we are activating with the whole prefix, which includes the path and the virtual environment's name. So we are not activating anymore only with the name, but with the whole prefix, which includes the path, the complete path, and the name of the virtual environment at the end. So activate, and if you see now we have not only created but actually activated the test-env environment. But in this case, as we created the environment with the prefix and not with the -- name, when it activates the environment, it shows here on the prompt between parentheses not only the name of the virtual environment but the whole path along with the name of the virtual environment or the prefix. And for deactivating it, always use Conda deactivate. Okay, now it's deactivated. So how do we confirm that the environment has actually been created along with the installed packages? as we installed it here, we simply look for the content of the current folder. And now we see the folder of the virtual environment not at our home /conda/envs, which is the default folder for when you create the environment using the name attribute, but now it has been created inside the current Python project folder and inside the test-env folder. So, and if you go to the test-env folder and list its content, you see some common folders for Linux Ubuntu root folder, but not on the root, but inside this folder of the virtual environment. So what Conda does is sort of replicate our main operating system inside one single virtual environment folder, so that we have all the needed system here inside the virtual environment folder. For example, the bin folder, the etc, the lab, the share, and all folders necessary for simulating the operating system here inside, isolating all the system we need as a subsystem of the main operating system we have, and also the packages that it has installed. It also includes here, along with this subsystem or this replica of the main operating system. So when you have a virtual environment activated, what you have is an isolation of the operating system, and you only have access then to this system here inside the virtual environment folder and not to the main system. So you can only access the packages installed inside your virtual environment and not the packages from outside or from the main operating system. And when you deactivate the environment, and only then you start having access to the outside operating system, file system, and packages. So from this first part of the command list, we saw how to use conda create, both with --name and with --prefix. And we saw the big difference between those two regarding mainly the path of the destination for the virtual environment folder, and that we will not be using the --name anymore. We'll be using always the --prefix or -p, because we always want to set exactly the place where the virtual environment folder will be placed into, and always inside our Python project structure. So we also saw the conda activate and the conda deactivate commands, as well as we saw how to remove all the packages from a virtual environment, which consequently deletes or removes the whole virtual environment folder or the environment itself. We also have the conda update, but we'll not be using it much, so you can read about it later. And this conda info is for displaying a lot of information about the installation of Anaconda, as well as its version, the existing environments, and so on. So let's test conda info here, only for you to see what it does. So at the terminal, we simply use conda info, and here you have a bunch of information about the conda application. Active environment, we have none. If we activated any of the environments, including the test-env, which we still have here available, it would appear here. The shell level, user config file, conda version, and conda build. The Python version available, which is 3.12. The base environment, which is placed at the installation folder at /opt/anaconda3. The channels URLs for the default channel we have available at our Anaconda installation. We can add later more channels, but the ones available by default are these ones. The package cache, which is at the installation folder / packages, and also here at the home /.conda / packages, as we saw. The envs directory, both at the installation of Anaconda as in the case of my home /.conda /envs. So we have the default folders for environments and for packages, both at the installation folder as at the home. So if you accidentally create an environment or download any package and you don't know where it is, you should look for the Anaconda installation folder /packages or envs, or you would look here at the home /.conda /envs and /packages. So either it would be placed at the installation folder and at the package or envs folder there, or it will be placed, as we saw in our case, at the home /.conda and then /packages or envs. That's why I do not like to create virtual environments using the default folders or the --n, because I end up without knowing where the packages actually are, not mentioning that the package end up being at a place outside the folder of the current Python project I'm creating. So I always like to create with the prefix -p, because then I can be certain where exactly the environment will be placed into, and place that always inside the current Python project I'm creating. So the platform, Linux 64, the user agent, the operating system, and so on. So now for checking this same command, conda info, with a virtual environment activated, let's activate the same test env environment, which still is saved here inside the test folder. So remember that for activating an environment created with the prefix attribute, we gotta pass the whole path and not only the virtual environment name. So if we try to activate the environment only passing the test-env name, it will look at the default places where Conda puts environments by default and it won't find it. Why? Because in this case we've created this environment with the prefix, and thus we have to always use the whole incomplete path or prefix for Conda to find it. So this virtual environment was not placed at default folders, envs folders, so we always gotta set the exact custom place where we've created in the first place. So conda activate home /anaconda /test/ and then the name of the virtual environment. So now it will find it, and now it's activated, and we can use again the conda info just to check what changes in the information shown. And basically it now shows the active environment as the test-env, because we've now activated it. The active env location, which is the prefix, observe that it uses as the name of the virtual environment the exact same prefix with the complete path / and the virtual environment name at the end, test-env. So both the prefix and the virtual environment names, in this case, when prefix is used instead of name, are the same. So that's basically the only difference for this command conda info when you have a anaconda virtual environment activated or not. So now let's see the other commands. So we saw these ones, and the next are these. One additional tip here is package dependencies and platform specifics are automatically resolved when using Conda. And that's what I have already said, that Conda will be responsible for not only installing the packages we ask it to install, but to look for all the dependencies needed for those packages. That is, the other packages that are needed for those packages we want to be used. Never we only need to install the packages we want. There are always additional packages or dependencies to be installed together. Otherwise, the ones we want will not work properly. So it's up to Conda to resolve all that, including the compatibility of the versions to be installed for each of those packages. So the next commands and subcommands are for listing the installed packages by using conda list, and we can pass also the attribute show channel URLs together, so that not only it lists the installed packages at the virtual environment, but it also shows the source where those packages have been downloaded from, or the channels or repositories of those packages. We can update all the packages using conda update --all. Remember that we used already the conda remove --all, passing the name of the environment to remove all the packages from inside that environment. And we also have the conda update --all, and eventually also using the name of the virtual environment, because when you are inside an environment with the environment activated, you do not need to pass the name of the environment where you want the action to occur, because by default Conda will do that action or that command at that currently activated environment. But you can, for example, want to execute that action, for example, either the remove or the update or whatever command you want to execute on other different environments and not that environment that's currently activated. So you can use or not the --name or -n when, for example, removing or updating packages in a environment, because you either may want to do that on the currently activated environment if you have any environment activated at the moment, or you can want to apply that command on other environments. So in that last case, you would have to pass the name as well. So for installing packages, we can install as we did already when creating the environment. So we used conda create the -p and the prefix of the environment, and right after, at the same command line, we also passed the package list of the packages we wanted to install at the same command line. So you can also create an environment, and only after the environment has been created and even activated, you then install any additional packages, for example, using conda install and the package name with or without the version, as well as you can also uninstall and here a specific package and not all the packages, because if you uninstall all the packages, the environment will be deleted, as we saw already. But you can uninstall individual packages of your virtual environment, either at the environment you eventually have activated or on any other environment by passing the environment name or the prefix. So we can install we can update, we can remove all the packages, or we can uninstall individual packages of a currently activated environment or any other environment using the -- name of the environment. For the channels, we can use conda config and then -- show -- sources for viewing all the available channels registered at our Anaconda installation. And by default, we have only one channel registered, which is the default channel. The name of the channel is default. But we can add how much channels we want, including, for example, we'll do that next. We can add, for example, the source forge, which is an additional famous channel that you can add. So there might be packages that are not available at the defaults channel or repository, and that you gotta have to add additional channels or repositories, including from different companies and not from Anaconda company, where you would finally find the packages you need. So anyone can create his own Conda and his own repository for Conda packages and turn that available to the Python community. So we can add any repository as channel sources, and then when the channel is added, the packages will be available for downloading and installation at our virtual local environment. And after adding channels, or for the channels we already have registered at our Anaconda installation, we can set the channel priority for telling Conda the prioritization or the sequence of the channels that it should use when trying to find any package we tell it to install. So Conda will obey the priority we set for the channels when we ask it to install a certain package, only telling the package name or the package name version without specifying or restricting the channel. So, for example, if we have the same packages available in more than one channel, and we do not specify exactly the channel we want for the package to be downloaded from, Conda will obey and follow that order of priority when looking for that package at the repositories. So now let's test at the terminal all these commands. So let's get back to the terminal. So at this part of the practice, we're gonna test or see how to use Conda to manage packages individually, as well as the sources or channels of the packages we wanna install. So we are gonna see how to list, how to install, how to define the exact source or channel for the packages we ask Conda to install, how to update a package, and how to uninstall an individual package other than removing all the packages as we already did. And also we will see how to add new sources or channels, and then how to use those additional channels for prioritization between the registered channels, so that Conda will follow that priority when looking for the packages we tell it to install. And for all that, we'll be using the already existing test-env. And if you see here, you see that I'm not with this virtual environment activated, because we have not the parentheses here with the name or with the prefix of the virtual environment inside. So we are in the deactivated state, and now leverage that to show you that, for example, for listing all packages, all installed packages, we use conda list. And as you see, in this case, as we are at the deactivated state, it's not listing the installed packages at the test-env, because we do not have all of these packages installed at the test-env, but it's showing the packages from the default installation of Anaconda 3. So these are all the packages available locally at the Anaconda 3 installation, and that Conda can take without downloading them again. If we ask it to install any of these already available locally at any virtual environment, it will only take these and install at the virtual environment we ask. So all of these are already downloaded at the local repository or the packages folder at the default installation folder /opt/anaconda3. So, and how can we see only the installed packages at a particular environment? We gotta activate that environment using Conda activate, and in this case the prefix with the environment name at the end of the prefix. So Conda activate home/anaconda-workspace/test/test-env. So I'm activating this test-env environment. Now it's activated, as you can see here. And now if we use again the Conda list, it will not refer to the whole Anaconda installation anymore. So it will refer now, or it will apply this command now only to the currently activated environment, which is the test environment. So it will show only the packages installed at the test-env. And here you have observed that now the number of packages is pretty much smaller compared to all the packages available locally at the Anaconda installation. So always remind that if you want a Conda command to be applied in a specific virtual environment, you either have to activate that environment first, including for using any packages inside that specific environment, or for applying a command on that environment itself and not outside it, or for some commands, but not for this one, you can also pass the -n or --name at the command line. So here for the Conda list, it's not possible to pass the -n, so you gotta activate first the environment and then use the Conda list if you want to apply the Conda list only at the test-env environment and not on the Anaconda installation as a whole. So you can also use Conda list along with the --show channel URL. And what's the difference? Let's see. It simply shows which is or which are the channels, if more than one, where we have installed those packages from. So it will show the packages with the version of the packages and the build identifier, along with the channel or channels where those packages have been installed from. So all of these packages from the test-env have been installed from this unique channel we have, at least for now, called defaults. So this is the only channel or repository that comes with the default installation of Anaconda, but we can add more channels as we are going to do right in the sequence, but only now for showing you the Conda list with the attributes --show channel URL for showing also the channel for each of the packages that have been downloaded from that channel's repositories. While we still at the activated state, while we still have test-env activated, we can also test the Conda update --all and it will update all the packages installed at the currently activated virtual environment. So, and have in mind that when we ask Conda to do any operation regarding packages, as one of its main functions is to manage effectively the packages, it will not apply any operation on the packages that will cause any conflict on the packages. So not only at the installation, but also on the update of the packages. For example, here, conda update -- all. Conda will be responsible for not letting any package version or build incompatible with the other packages to be installed or updated. So it's up to Conda to validate first if the versions and build number of each of those packages installed or that we are asking it to install are compatible between each other. If one version, for example, is not compatible, it will take a previous version or else a previous version until it finds any version or build that will turn compatible the existence of that package with all the other packages. So in this case, it will update all the packages except if the update of a particular package will bring any consistency to the whole set of packages. So it will update in a securely way without introducing any compatibility for those packages collection. So that's the biggest advantage of Conda in my view, because if you ever tried to manage packages for development manually, either in Python or in Java or in whatever other language or development environment, you should remember the whole chaos that it may bring. So always have packages managed automatically for you through package managers, including Conda applications. So still on the version 3.11, it won't change the version, but still on the version we set Python, for example, to be installed, version 3.11 and not version 3.12. In this case, Conda is telling us that two packages can be updated: the OpenSSL package from this version and build number to this newer one, as well as the Python package that we have asked Conda to install from this version or distribution 3.11.0 to this other version 3.11.9. So it can update to the latest distribution of that specific version we set to be installed, because it already implies that we do not want newer versions of Python to be installed, but still at the version 3.11 it's telling us that there's a more recent distribution and is asking if we want to update. So yes. Okay, and all update transactions have been concluded, and if we check Conda list again for the currently activated environment, it will show the updated packages. For example, the Python package now with the version 3.11 but with the 9th distribution instead of the 0.1. So it has updated the Python package as well as the OpenSSL package. Okay, that's for Conda update. So now for installing individual packages or for installing lists of packages but not using Conda create, which is the way we have already used it to install packages on the same command line when creating the environment. Now, after we have the environment created and we have the environment at the activated state, as it's the case of the test-env, we can install additional packages or an individual package by using not Conda create but Conda install and the name of a particular package or a list of packages, the same way we did with the Conda create, but now we are not creating any environment, we're just installing the packages on the currently activated test-env environment. So Conda install, let's for example install matplotlib. We can set the version or not, and you can find these packages at the documentation or on any browser search. Just look for Conda packages and whatever package you want, and then you find the exact name to use here. Add the Conda install and the name of the package. So you gotta pass the exact official name of the package here, otherwise Conda won't find it at any channel. So when we tell Conda to install a particular package, it will look on the list of channels registered at the Anaconda installation. If that package name exists in any of the channels, and if it exists in more than one channel, it will follow the priority sequence we've set when configuring the channels. So as you know, we can set the specific version. I don't know the version sequence of matplotlib, but for example, if it was this one, we would simply use the double equal with the version of this package we want to install, and we can also use or set the specific channel we want this package to be installed from. But in our case, as we know, we only have the default package added. So before we try to install a package from a different channel, we first have to add that channel to the registered channels at our Anaconda installation. So as we only have the default channel installed or registered, we can't try to install matplotlib package from any other channel before adding that channel to the channels list at our Anaconda installation. So I will show you how to install from specific channels after I add more channels. For now, I'll simply install as this, Conda install matplotlib and enter. And it will take the latest stable version of matplotlib and all the dependencies related to it, the correct versions, latest versions, as long as those versions are not incompatible with the other existing dependencies or packages installed at the virtual environment. And we can just confirm and it will install. So this is the way of installing additional packages after the virtual environment is already created. Because before the environment is created, the easiest way is to pass the list of the packages you want to install right in the command statement of the Conda create. But if you miss any package to ask Conda to install, you can later, after the environment is created, you can activate the environment, which is what we did, and then ask Conda to individually install those additional packages to that currently already existent and activated environment. So how to check that? With Conda list and being at the activated state. So these are all the installed packages at the test-env, and if we see here, we have now the matplotlib with the latest stable version and the build identifier. And as we know, we can also pass conda list -- show channel URLs to list also this column channel with the source of installation of the repository which we have used to install each one of those packages. In this case, always is the default because it's the only one we have, but now we'll start adding additional repositories or channels, and then we'll start installing our packages from specific and different channels for you to see that that's actually possible. But before that, let's already test Conda, uninstall, and observe that here we are not removing all the packages of the current activated virtual environment. We are only uninstalling one single package, which will be the, for example, matplotlib that we have just installed. It will uninstall only the matplotlib and leave all the other packages in their place. So conda uninstall matplotlib. It will confirm the uninstalling, and also observe here that it removes not only the package we are telling it to remove, but similar to when we install, also when we uninstall, it will cross-reference all the other dependencies or all the other packages that will not be needed to other packages and that have been installed together with this particular package we are uninstalling, and actually remove all of them so that we do not keep with a bunch of useless packages at our virtual environment installation. So proceed, yes. It will uninstall all these packages including the matplotlib one. So uninstall. Transactions concluded. Let's check with Conda list. And if we look for matplotlib, we won't find it. So it has been uninstalled successfully. And now let's work on the manage of the channels and repositories. So still with the test-env virtual environment activated, we want to show now all the channels available. And for that, we can use conda config. For managing channels, you will always use the config. So conda config -- show sources. So with this command, conda config -- show sources, it will simply show all the channels at our Anaconda installation. And you have here the channels list with only one single channel, which is the channel named default. So, and how we can add additional channels? We can do that by using the conda config, but now passing the attribute add, and add what? Add channels, and the individual channel name that we want to add. You can also look for the list of existing channels at the documentation or at Conda community or at Google search or any other search engine, but you gotta pass here the right channel name, otherwise it will give an error message telling you that that channel doesn't exist anywhere. So you gotta pass a valid channel name here if you want it to be added. And the one that's very famous is the Conda Forge. So let's add this one. Now if we see again the list of channels available by using conda config -- show sources, it will now show both channels available, the defaults, and the just added conda forge. So now every time we try to add a package, it will look on both channels and it will follow the priority list. First it will check on conda forge, and if it doesn't find the package with that exact name and eventual version at Conda Forge, then it will look into default channel. So let's test that. So let's install now again matplotlib by using Conda install -c. This time we're gonna set exactly the channel we want matplotlib to be downloaded from. So conda install -c or dash channel, the name of the channel, in this case Conda Forge, and the name of the package, matplotlib, with or without the version. Okay, now it's fetching exactly at the Conda Forge channel. It's collecting the package metadata. Then it solves the environment and creates the package plan of installation of the package, the environment location where the package will be installed at, and it's the prefix of the currently activated test-m environment. Here it confirms the package that we asked it to install. Here it confirms all the other packages necessary for matplotlib to run. And observe that now it's listing as the source of those packages, not the default channel anymore, but the conda-forge that we've now been able to specify, because we have already added this new channel to the sources list. So the following new packages will be installed from the sources above. Here again, for example, it shows the package name, whatever package it is, the source of the package, and you see all of them will be installed from the Conda Forge. Then the platform, Linux 64, then the version and the build of the package. So, and it also automatically updates any necessary installed packages for guaranteeing that the packages being installed will work properly in case they need more updated dependencies regarding the dependencies already installed. So it will install all those packages and update these other ones. Also from Conda Forge. So let's proceed and wait Conda to conclude. Now it's concluding the transactions and ready. So let's check the packages again and showing the channel URLs of each one. And let's see the matplotlib if it has been installed. Here it is, matplotlib version 3.9.2 with this build identifier. And now instead of default channel, with the source being the Conda Forge channel or repositories. So now we have some packages from Conda Forge channel, both matplotlib as those other ones that were updated to the builds from Conda Forge, and we also still have some packages from the default channel. So that's how we work with multiple channels when managing our packages with Conda. Okay, so now that we have learned already how to create and activate and deactivate and remove environments, as well as how to manage packages and channels, let's proceed by learning the main commands and subcommands for managing the environments themselves. So we have already learned how to create, activate, deactivate, and delete a whole environment. So now we're gonna learn how to list all environments and their locations with the conda info --envs If you remember, we've already tested Conda info for the Anaconda installation as a whole. Now we'll test for the particular existing environment. And for that, we just have to use the --env attribute or parameter. Then we'll test the list, the install, the uninstall, and the update, but in this case being at the deactivated state, only to show you that you can add the deactivated state, execute any of these managing commands over the environments for listing, installing, uninstalling, and updating the packages of a particular environment by using the -n or --name and the name of the environment, or the prefix. If you created the environment using the name, you only have to pass the name. If you created the environment using the prefix, the name will be the whole prefix. Okay, all these commands we have already seen, but we were at the activated state. Now we'll re-execute them at the deactivated state, but passing a specific environment name so that Conda can know on which environment proceed those actions. So you can either use these package commands when you're with an environment activated without having to use the -n, because Conda will imply that you want to use those commands on the currently activated environment, or use the -n to proceed with the action, even at the deactivated state. So that's what we are going to test now. So let's get back to our turn. So still in the activated state with the test-env virtual environment activated, I wanna show you the Conda info, but now it won't show the info of the Anaconda installation because we are passing the envs attribute. So that way it will show the information of all available environments. For this environment that's activated, it will show an asterisk or a star to mark which environment is currently activated. So if we wanna see the information about Anaconda installation, we simply use Conda info, or if we wanna see all environments available at the activated state or at the deactivated state, we simply pass the --envs attribute or parameter. So let's check it. So that's basically it. We have actually two available environments, and this is the information of those two environments that it by default shows with the Conda info --envs. So it shows the base environment. The base is the name of the environment, and here it shows the location where that environment is installed. So we have the root/opt/anaconda3, which is the installation folder of our Anaconda installation, and inside we have the base folder with the base environment. And we also have this environment that we created with the prefix, and because of that it doesn't show the name because we didn't pass any name. The name ended up being the same prefix that we passed because we used the prefix attribute and not the name attribute, and you cannot use both. Either you use the name or you use the prefix attribute. And in this case, for the test-env, it shows a star or asterisk for showing that at the moment this is the currently activated environment. So if we simply deactivate it, Conda deactivate, and see again, conda info dash envs, now there will be no more star to mark the activated environment, because now no virtual environments are activated anymore. So we still have both environments available for activation, but none of them is activated anymore. So that's it for the conda info with the dash envs attribute. Now that we're at the deactivated state, I'll show you that we can use the same package command that we used, but now having to specify which virtual environment we wanna apply those commands on by using the dash name or dash n. For example, if we wanna list the packages installed at a certain virtual environment that is not activated, we can show it the same way by using conda list. If you want dash show channel URLs, but now we gotta tell conda which virtual environment we wanna list those packages from, because every environment has its own packages installed. So if we simply tell conda to list the packages, it will show the packages of the base installation or the packages of the anaconda installation. It will not show any particular virtual environment packages. If we wanna show the packages installed at a particular virtual environment that is not activated, we simply pass the name of the environment, or in this case the prefix, because we've created the test-env using the prefix. So -p anaconda workspace test-env. So now it knows which virtual environment to list the packages from. Okay, so we didn't have to activate the test-env because we can simply pass the -p specifying which environment we wanna apply that command, in this case the list command, on. So the other packages commands, we have already seen them. We can install and update the packages individually at a certain environment, but in the case that we are not with that environment activated, we can proceed just having to specify using the name or the prefix which environment we wanna modify. So for example, we can, without activating the environment, we can use conda install a specific package, for example scipy, and install that package at a specific virtual environment by telling conda which environment that is, because we are not with that environment activated here. So we have to pass the -n or dash name, or in this case the -p or dash prefix for specifying which environment we want to install that package on. So home / anaconda / test / test-env. So without activating the test-env, we'll install this package scipy at the test-env simply by specifying here the prefix identifier for that virtual environment. Confirm. So it's installing scipy at the test-env virtual environment without us having to activate the environment first, because we specified the prefix of the environment. So it knows on which environment to install the package. Then it says it's downloading these packages, including scipy, from the Conda forge, and observe that it will follow the list of the available channels, beginning with the first top one. So first it will look at the Conda forge. If the package does not exist at it, only then it goes to the second channel available and so on. So it follows a natural prioritization. So beginning with the first top channel and going down throughout the whole list of channels available. So in this case, it finds all the packages at the Conda forge, so all of them will be installed from Conda forge. Okay, yes, and it's installing scipy and all transactions completed. So now we can list again without activating the environment. We can list the same way by using Conda list -- show channel URLs and -p for specifying which virtual environment we are referring to, and the prefix. Where is scipy? It's here. So scipy version 1.14 with this build installed or downloaded from Conda forge. Okay, so we list it, install it, and now let's uninstall in a similar way by using Conda. Instead of install, uninstall scipy and setting the prefix in this case, or if it was the case, the name for the virtual environment we want to apply that command on. So enter, yes. So it will uninstall the scipy from the test-env because we passed the prefix specifying which virtual environment we are referring to. Otherwise it wouldn't know because we are not with that environment activated, and it succeeded in removing both scipy and the other related packages. If we list again, we won't find the scipy package anymore. And finally, we can update a package without activating the environment by using also the same way the name or the prefix attribute. For example, Conda update -- all. You're gonna update all the packages to compatible versions, so not necessarily to the latest versions, because it might be that the latest version of any of the packages may be incompatible with the other packages available, so it will install to the latest version as long as that version is not incompatible with the other versions available. So Conda will always take care of the versions regarding compatibility, no matter what we ask it to do. So Conda update all, and then we pass the prefix again to tell it which environment we are referring to, because again we are not with that environment activated. So -p home /anaconda /test /test-env, proceed. It will update at this environment test-env because we passed the prefix. Okay, and it's finished. So that's how you execute any command as long as the command accepts that attribute, either passing the name of any deactivated environment or the prefix, so that Conda can identify which virtual environment you want to execute that command and subcommand on. So these are examples of commands and subcommands of Conda for working with Conda environments when they are not in the activated state, And now let's see some other commands for working with the environments themselves. So for working with environment management. And this very important step here that I have already commented before, specifying the environment name confines Conda commands to that environment. So either if you activate a specific environment or if you specify the name or the prefix of a specific or particular environment at any command of Conda, it will restrict or confine the execution of those commands to that specific or particular environment without affecting any other available environments, let alone the base environments. So this is a big advantage of working with virtual environments because you protect all other environments of the other projects, because you will only affect that project and that environment you were activated at, or that you pass the name or the prefix to the command. And one mistake that occasionally may occur is that you tell Conda to execute a command and you forget to pass the name or the prefix of the particular environment you want that command to be applied on, and Conda will eventually execute that command on the base environment. So just be careful to either activate the environment you want to apply those commands on, or even at the deactivated mode, pass always the name or the prefix of the particular and correct environment you want to use. So let's test these. We actually have already tested the Conda create, passing the dash name or the dash p environment name and the list of the packages we already know we will need, so that in the same command line it creates the environment and takes the packages and eventually the versions of those packages to install. So this one we have already done. There's also this clone. You can clone one environment into another for working only with the other one, and in any case go back to the other one unchanged. So you can clone an environment for doing some experimentations on that clone without risking destroying or creating any conflict on the original one. So I'll not actually execute this because it's not much relevant. But we have this one, Conda rename -n, and then you pass the current name of an existing environment and then the new name that you want to have that environment changed to. So first the current name, the existing name, and then the new name you want to apply to that particular environment. So let's test this one, Conda rename. And this one, Conda remove, we also have already used and tested. This removes all the packages because we use the --all. So all packages of these environments are deleted and automatically the package itself and its folder is also removed. So this is how you remove an environment, as well as this is how you create an environment. You can also list revisions made to an environment. Any change you do to an environment, Conda keeps a revision of that transaction. So if you want to return or restore a previous state for that environment, you can use the Conda install the name of the environment or the prefix along with the -- revision number. First you check which revision you want to restore, and then you restore that environment name by passing the revision number you wanna get back. So we'll try this one to know how to restore a previous environment state or revision. And also we have this one to uninstall a package from a specific channel. For example, we have tried already to remove a specific package from a specific environment, either being at the activated state or at the deactivated state. But we can set also the channel of the packages we want to remove from that certain environment. For example, in the case we have more than one package from more than one channel, and we want to remove one of the packages of a certain channel. This is very unusual to have more than one package with the same name from more than one channel, so I'll not test this one. So let's test now at the terminal. The Conda rename the Conda list with -- revisions and Conda install with the -- revision number. So let's get back to the terminal. So at the deactivated state, how to rename a Conda environment? We call Conda rename -n or -p. In our case here is -p for the test env. Home anaconda workspace test /test env. This is the current prefix, including the current environment name. And now we pass the destination, and if we simply pass the new name, it will move the contents of the test env environment to the new folder or environment with the new name that we pass here, but it will put the environment inside the default packages envs at the home /.conda folder, and we do not want that. So how do we do to specify the complete path where we want that environment to be set into? We simply pass the prefix again, but without passing the -p parameter again. So we only pass the -p parameter once, then the source, and then directly the destination, which is also the complete path to the current directory. But instead of test env, we'll try a different name, test-daniel-env. Okay, so here it confirms the source environment name and the destination environment name, and the name is also the folder name, and the path keeps the same because we passed the exact same base path, but we could have passed any other path at our file system or any remote path to move that environment content to. Okay, so now if we check the content of the current folder, test folder, now we have this test-daniel-env folder for the new environment name. And if we check conda info -envs, it now shows again two available environments, but the previous test-env environment now is called test-daniel-env at the same base folder here. So let's change it again to test-env, so we simply gotta reuse this command here, using the source as test-daniel-env and the destination as test-env. Okay, so now we have the original name back, test-env, as well as the whole folder structure, test-env as originally. Okay, so now let's work with the revisions command, the two revisions command that we have. The first one is for listing all revisions of a certain environment, and the other one is to restore a previous revision with the install command, in both cases using the attribute -- revisions. So, for example, let's show all the revisions from our test-env environment. As we are not with test-env activated, we gotta set the name or the prefix of the environment we wanna act on. So -p home anaconda -workspace test-env. So this is the environment. If we only use this, you remember that it will list all the packages for this environment, but what we want is to list the revisions, so we gotta also pass the attributes -- revisions. So it will list all revisions for this specific environment. So these are the revisions, and basically we have only one revision actually. So, and why does it show only one revision? As we have already changed a lot of packages and even the channels, because we changed the name. So when you rename an environment to another name, it basically destroys that original environment folder together with all the revisions existent, and it starts a new revision history on the new environment name folder. So because we did that, we kind of reset the test-env revisions history. So for us to create another revision, let's simply install a new package here so that we can alter the state of the current test-env and thus create at least one more revision, so that we can then revert to a previous one, in this case for the 0 revision. So you can do that by using Conda. We can install or we can uninstall any package, and we gotta tell which environment we want to act on. So we pass the prefix home / anaconda workspace /test/test-env. So we wanna uninstall from this environment at this prefix the packages pandas and numpy. With this, we alter the state of the environment, test-env environment, and it's added a new tree at the revisions history of this test-env environment, so that we can go from one revision to another, simulating here and rollback of the state of the environment. So we are removing these two packages and altering the state, and thus creating a new revision for the test-env. Okay, we are ready. And now if we check again the list of revisions for the test-env, we now have at least 2 revisions. The original revision when the test-env was recreated and had this state history reset. But now we have another revision which was regarding the uninstalling of numpy and pandas. So suppose we ended up in a inconsistent state for the current environment. How could we roll back to the revision 0, for example? Very simply, instead of Conda list, we would use Conda install, then the prefix or the name of the environment, and then the attribute revision in the singular and the number 0 for the 0 numbered revision. So now we roll back from the current revision 1 back to the previous revision 0. So I guess there might have happened some bug here. It's not managing to revert the state of test-env environment, so I'll just cancel it with Ctrl C. And I'll try to alter one more thing to create a third revision, and then I'll try again to revert instead of to revision 0 to revision 1. So I'll create now the revision 2 by altering here another package. I'll simply install scipy again. Instead of uninstalling, I'm now installing a new package. Okay, I have altered the state of the environment test-env again. Let's list the revisions again. So now we have revision 2, and the difference is scipy installed. We have revision 1 and we have revision 0. So now I'll try to revert. The current revision is 2. I'll revert to revision 1. Okay, finally it's managed to retrieve all the metadata for the reversion from revision 2 to revision 1, returning the virtual environment to the state of the revision 1. So here again it asks the approval for the package installation plan so that it can alter the states again and revert the current state to the latest one in this case. So proceed. The transactions have been made. And now let's list again the revisions. And actually we have one more revision added. It does not erase the revision, so we had revision 0, then we changed to revision 1 when we uninstalled pandas and numpy. Then we added revision 2 when we added scipy, and then we reverted to revision 1 state, but it, in terms of revisions, it creates another revision with that same state of revision 1 that we asked it to roll back to. So it creates another revision, even though when it gets back to a previous state of a previous revision. Okay, so that's how you list and roll back or install any existing revision or state at your Conda environments. Okay, so now let's continue our command list, and we gotta now test or see how to export and how to import environments. This is one of the most important things when using Conda to managing your environments, because when you create an environment, as we have done, Conda will install a lot of packages inside that environment according to what you set to be installed. And as you see, it's not only the packages we set, but a bunch of respective dependencies so that those packages can be run. So an environment in average takes up to 1 GB. And if you ever used, for example, GitHub, you may know that 1 GB is a very big size for having as your source code size or remote repository of your sources. So instead of sending your whole environment either to other local machines, for example, in different sectors of your company, or even at any remote repository, you can, for example, only export your current existing environment to a YAML file, which is basically a text file, which does not take almost any memory. It takes only the memory of a simple text file and not 1 GB. So you can export remotely for GitHub, for example, for others to take as an archetype of the environments to be recreated elsewhere, only the YAML file instead of the whole environment. And also for other local machines, if you want to recreate your environment at other places or other machines or servers in your company, you won't have to copy this whole bunch of data. You will simply share your YAML file after creating it from your current and most recent existing environment. So instead of sharing your environment, you will share the descriptive text file, which will contain all information of that environment, and that will save with whatever name you want. Generally, it's saved as env.yml or YAML, or with the complete name environment.yaml. So let's try this to export our existing test-env environment to a YAML file, and then we'll delete the environment, we'll remove the environment, and we'll recreate the environment as we were, for example, at another machine or on the other side of the world, getting your open source project and taking only the YAML file and recreating the same environment elsewhere by using the environment creation along with the environment.yaml. So I repeat, this is very important for when we start using GitHub, which we'll be using pretty soon, because we'll never export or we'll never upload or we'll never push our environment to GitHub. Why? Because it's too big and it's unnecessary. So what are we going to do? Instead of pushing the environment folder with all the data of the environment, we'll create the environment.yaml, and together with the project sources, we'll push all that except the environment content to a GitHub remote repository. And then anyone, anywhere in the world with internet available can clone the repository at GitHub, have access to that environment.yaml, and using Conda, recreate the environment locally in exactly the same environment we had here when pushing the code to GitHub. So here we still have, if we use Conda info -env, we still have test-env locally available. So for exporting an environment content to a configuration YAML file, so that later anyone can recreate that environment from that YAML file, we first gotta activate the environment. So Conda activate the prefix. Okay, now we have test-env activated. So now we can export the environment configuration by using any of these three means. The first is the most advisable one, which is cross-platform compatible. That means that if you export your environment configuration to an environment.yaml using this first way, you can recreate that environment in any platform, despite it being Windows or macOS or Linux or any other platform that supports Anaconda. So we'll always prefer using this first way of exporting our environments to YAML files, because you never know, the person that clones our GitHub remote repository in order to run our project, which operating system the person is going to use, or even us, if we want to recreate the same environment on different machines with different operating systems. You never know which operating system we are gonna need, so it's always preferable to have a cross-platform compatible environment YAML file. So, but there's also this other way. If you're certain that any person that's going to use your environment is always using your same operating system, so you can simply use this other one without using the -- from history attribute. So the first way is to use Conda export -- from history, then this sign here, greater than, and the name of the YAML file, for example, environment or env.yaml. And the second way, which is not cross-platform compatible, it's platform specific, you only use Conda export the environment name, or if you were in the activated state, then you won't have to use the environment name, then the greater than sign here, and the name of the environment.yaml configuration file. So you either use the -- from history attribute or not. If you use -- from history, your environment.yaml will contain only configurations that are acceptable in whatever platform you're gonna recreate that environment by using Conda. And if you do not use this -- from history attribute, then it will include also some specific platform configurations at your environment.yaml, and that may cause some inconsistency in case you try to recreate the environment at some different operating system. So the second way, it may or may not work for recreating your environment in a different operating system machine, while the first way is guaranteed to be compatible regardless of the operating system of the machine anyone chooses to recreate that environment at. And also the second way, when you do not use the from history attribute, it also not only restricts the platform but also the packages. Why? Because it adds information about the packages, and it's exactly that information about the packages that turns the recreation of the environment from this kind of YAML files specific to the platform, because for every platform you have specific packages. For example, for Windows you will have some specific package from a specific channel from a specific build of pandas, while for Linux you have another one, for macOS you have another one. So if you include the package information on your environment.yaml file, when someone else is to recreate the environment using that YAML file and the operating system he's using is different, maybe that specific system package information that will be used to import the packages will be compatible. And maybe Conda will not be able to resolve the issue. So if you have to have restriction regarding the exact package and build of a certain package, you would eventually have to have this restriction to only recreate that environment at a same operating system machine, because the package specification would also restrict the operating system. And the third and last way to do it is even more restrictive, because it will restrict the packages and builds of the packages, and it will also restrict the channel. So when someone takes this environment.txt or YAML to import and recreate the environment, the person will have to have the same operating system you had when created that export file. The package versions and builds will inevitably be the same, as well as also the channels from which those packages will be imported or downloaded from. So the platform, the package, and the channel information will all be configured at the export file. So, but in most cases, the first way is the better way to do it, so we will keep using it all the time. You do not have to specify any specific package, let alone any specific channel. So we will simply specify the package names. So our environment.yaml will only contain the name of the packages, but not the builds of those packages or the channels where those packages should be imported from. But depending on your scenario, maybe you would have to choose any other more restrictive export file. So let's test that. So we are with our test-env environment activated. So you just have to use Conda export. In this case, we will use the least restrictive configuration YAML file. So we'll use the -- from history attribute, and then here we type the more than signal, and this will simply take the text information here and save into a file, otherwise it will only show up on the screen. So we want to save this information into a file and not simply showing on the screen. So we gotta use the greater than sign and then the name of the YAML file, which can be environment.yml. So Conda export -- from -history greater than environment.yml. So it will take all the names of packages and other informations of the environment we have activated, which is the only environment we have here, test-env, and put all the information into this YAML file so that later anyone elsewhere in the world can take this YAML file and recreate the environment we have here, exactly the same environment, test-env. Okay, so let's check the contents of this folder again. And here you have the environment.yml, and you can use the cat command from Linux to simply see the content of this environment YAML file. So in here you have the configuration for all the dependencies, so that Conda can later install all of these dependencies on the new environment created or recreated from this YAML configuration file. So all the packages will be here on these dependencies list. And finally, you have the prefix. Up in the start of the file, you have the name of the environment, and down below you have the prefix. But in this case, the prefix is exactly the same of the name, or the name is exactly the same of the prefix, because there's no name reset. And as I said, Conda takes the same prefix whole name as the name of the environment. So here at the YAML file, always it's set this way. So when another person takes this YAML file to reproduce the environment, he or she will have to take care, if the person doesn't want to install using the same folder structure that we used at the original environment, the person would simply change. For example, instead of this prefix, the person could change to the person's own home, for example, /home/Mary/ and the rest would be the same. So the person can change either the prefix or, if it's the case, the name. And regarding the name, if the person only sets the name here without the path, then Conda would put the created environment also at the home/.conda/envs default folder, and not here at the equivalent folder the person would want. So if the person wants to recreate the environment, putting it at the same equivalent folder that we've used here, he or she would have to alter this, just substituting, for example, my name for the person's name, but keeping the whole path along with the environment name, both here at the name as here at the prefix. And then Conda would recreate exactly at this path. Okay, so that's how you export your environment to a YAML configuration file. Later, when we try the IDEs, I will show you how to export that to a remote repository, in our case the GitHub remote repositories. Here we're exporting to a local file all the configuration needed to recreate the test-env environment, but not yet to GitHub. So now we can, for example, using sudo rm or remove -rf. Actually, we gotta deactivate the environment first. So conda deactivate. Okay, so now that we are not in the environment anymore, we can, for example, delete this environment, this whole environment. And we already know how to delete it. We simply uninstall or remove all its packages, and automatically Conda will delete that empty environment. So Conda remove, we gotta pass the prefix as we're not with the environment activated, so environment -all. So again, we're removing all packages from test-env environment, and Conda will automatically right after exclude the environment as a whole. So pay attention that we are not excluding the project folder, we are excluding only the folder of the environment, which is the test-env folder. So that's why the environment.yaml should be created here at the root of the project folder and never inside the environment folder, because if we put the environment.yaml inside the test-env folder, when we removed or deleted that folder of the environment, we would delete also the only way to recreate that environment again, which is the environment.yaml file. But as we have the YAML file here outside, we can delete safely the test-env environment folder. So we're deleting all the packages inside, and then Conda will also delete the folder itself. Okay, so it deleted all the packages inside. The following packages will be removed from the test-env folder, and at the end, as there were no packages anymore, it asked everything found within the environment test-env, including any Conda environment configurations and any non-Conda files, will be deleted. Do you wish to continue? Yes. Okay, so we can see now that the environment folder has been deleted along with all packages within. And now the only thing we have here, as we do not have any source code from any Python project yet, the only thing we have is the environment.yaml file. So how can we recreate the environment again? Either we or anyone else in the world that have access to this content now without the environment folder. Very simply, we simply use conda, and in this case the command is not conda create, it is conda env create. So it's important because if you try to use conda create, it will not work. You gotta use conda env create, then the name of the environment, or in our case the prefix, so -p, and then the path to this current Python project, so home/anaconda-workspace /test, and the name of the environment, so test-env. So if you use a different name from the name or prefix contained at the YAML file, it will overwrite that. So it will consider this prefix you're putting here. Conda env create the prefix, then the attribute dash dash file to tell Conda that you're creating from a YAML file or text file. So dash dash file and then the name of the YAML file that you had access to. So conda env create the prefix, then dash dash file and the name of the environment.yaml file. So let's recreate the environment from the environment.yaml file. Okay, as you see, it has registered or confirmed that the two source channels are already registered at our installation. Then it's collecting the package metadata to solve the environments and then install all the packages. The ones that are not present locally, it will download. The ones that are already present locally, it will retrieve from the local repositories of the Anaconda installation. Then it concludes the transactions for each one of them. And here is the confirmation that the environment has been created, which is the suggestion of how to activate the just created or recreated environment. So confirming here that the prefix has been used correctly, so it has been recreated exactly where we want it, which is by using the prefix /home/dani/anaconda workspace/test and /test -env. So with the same name at the same place, with the same dependencies and packages. So we can use this line of code again and have it activated. So now we have recreated and activated the same environment by simply taking as information the environment.yaml file. And in case you had, for example, created a text file instead of a YAML file, the only difference is that you would create the environment using conda env create. You would set the same prefix, and you would also had used the dash dash file attribute, but at the name of the file you would have passed the extension txt, for example, and not YAML. So I'll not do that. That's exactly the same. So now let's go to the last part, which are basically some additional hints of commands you can use. For example, for showing the help for any command you want. I guess we have actually already seen that. You can use, for example, conda -- help or conda any command, for example, create or conda env create and -- help. As for any other Linux command, any CLI interface, they all have this -- help attribute for showing some help for the commands and subcommands of that operating interface. And here with conda is not different. So here also you may use the conda search and the package name and -- info to have information about some specific package. You can try that later, it's very simple. When installing a list of packages, you can use the -- yes for not have any confirmation asked. So you will go directly through all the installation without having any prompt question for you. It's also a pattern for any Linux installation. You can, for example, clean unused files by using conda clean --all when you are at your environment activated, or by passing the name along with this command line. And you can see conda config --show to show or examine the conda configuration. So we've seen all the main commands and subcommands of conda in order to manage environments and manage packages, and also, very importantly, for exporting our environments to YAML files and later have those environments recreated elsewhere from that single and very short size text file. So that's it. If you wanna any more details about the conda syntax, just go to the documentation and you have a lot of additional information there for you to learn.